Now, see why the domain x must be equal to 3 or more than 3. Very simple. Look at this function here. 2 plus square root. Okay. The value inside here, x minus 3, for it to be a value that where you can calculate a real number, then x minus 3 actually must either equal to 0 or more than 0. Okay? Then only you can have a value. Okay? You can have a square root of a 0 or positive value. Okay? 0 bigger than 0 or more than is a positive or bigger than 0. So it's important that you have x equal to 3 or more than 3 to maintain a square root of a 0 value or a positive value. Okay? Now, that is to explain why the domain has to be equal or more than 3. Now, let's look at the range, that means the fx value. If you maintain x to be equal or more than 3, then this side here is always positive. Okay? So square root of a positive value, you will end up with two possibilities. First is 2 plus the square root, the positive value of the square root. Okay? You also can have another case whereby fx is equal to 2 minus square root x minus 3. Okay? Now, 2 plus, this is always positive. Okay? Now, what about this? If we consider the negative value of the square root, you will realize that 2 minus this value, you end up with smaller than 2. Okay? So this is more than 2, this is less than 2. So if you increase the value of x, if you take the positive value of square root, then the function, the range will continue to increase as x increase. If you take the negative value of x, if you increase, the negative value of the square root, if you increase x, so this whole thing square root will, the negative here, will also increase. So 2 minus the increasing value, this value, so you end up with a more negative value. Okay? In other words, the range can be any value. Okay? You can, as long as x is more than equal or more than 3, then y, the function value actually become can be any value. Like this case is a very positive value. This case is become, as x increase, become a negative value. Now, how would this look like now? Let's y equal to fx. Okay? Now, so y equal to 2 plus square root x minus 3. This bring over y minus 2. So this is x minus 3. Now, if you square both sides, then you come y minus 2 square. So it's x minus 3. So x become y minus 2 square plus 3. Okay? Now, if you look carefully, this is similar like completing the square, but then the x and the y change. If you look at the similar pattern, would be this: y equal to x minus 2 square plus 3. Okay, this is the normal completing the square, whereby if you do it, it will some sort like that. Y is here, x here, and it looks some sort like that. Okay, now so it look like that, where y subject, x is the input variable. Now, what about this? You see, in this case, x is the subject, y is the input variable. So the graph actually become like that. Instead of this manner, then it becomes some sort like that. Okay. Y equal to minus 2. Yeah. Okay. So this should be 2 here. Now, equal to 2, x become 3. Okay. So, it looks some sort like that. It's inverted. Okay. Now, this point here is 2. Okay. The minimum value of, in this case, is x. Okay. The minimum x value will be 3. Okay. And then the axis of symmetry in this case will be y equal to 2, y equal to 2. This is how the graph look like. Okay. So if this is the case, what would be the value of y? What will be the value of y? Now, you see, if you open it up, this continue to increase. Now, what about this part of the graph? Will it cross? Can it possible y become 0? Now you look at this equation again. Can y become 0? Yes. Y is 0. You still can find an x value when y goes to 0. So that means the curve actually passes through this point here. You go up this way. Okay. So in other words, the y value can be maximum infinity as this curve extend outwards. Okay. And then this one extend this manner. So you can have negative infinity. Okay, so to answer this question, x, the function, wait, that's right, this manner, the function can be any value, any real value, okay? Can be any real value, no restriction. The only restriction is the domain x must be bigger than or equal to 3. Okay, now next question would be find expression of the inverse function. Let me make from here, make x the subject first, which I did here. Now let y equal to function, the original function, and then also become y, then bring the 2 over here, and then square both sides. So you at this stage here, you already make x the subject. Therefore, this one, the x become the inverse function, the y become the x plus 3. That's it. So this is the inverse function. Now let's look at this. Gx equal to 12 over x plus 2. Now, gfx, what's the meaning? That means g bracket x fx. I mean, we're going to replace the x of the g function with fx. So this become, where is the g function? G function is this, so 12, this is x. We're going to replace with fx, okay? Plus 12. What is your fx? Is 2 plus square root x minus 3. Okay, let me repeat again. Because instead of finding the gfx, it gives you the x is 12, so it's very straightforward. Then this is g, okay, bracket x equal to f12. Okay, now g x f12, what do you get for f12? Let's substitute here. And f is equal to 12, is 2 plus 12 minus 3, 2 plus square root 9. So this gives you 2 plus minus 3. Okay, square root 9 can be plus minus 3. Or remember, wait, fx become 12. Okay, now let's come back to this. Let's look at this. This bring it over here. So the fx 12. If you, let's look at the two value, 2 minus 3 or 2 plus 3. Taking the positive and negative side of square root 9. 2 plus 3. This is minus 1. This is 5. Okay, now. So we have found f12 is either minus 1 or 5. But x equal to minus 1 or 5. Because f12 is actually x equal to minus 1 or 5. But since x say bigger than 0, so we're going to select f12 equal to 5. So this becomes 5. Okay, now, so your g function where x equal to 5 is equal to 12 over 5 plus 2. So this is 2.4 plus 2 become 4.4. Okay, that's it. cost function dimension about, okay. So this answer, and then this the function value, whatever value can be elements of the real number. That means the function value can be any value.